Okay, we're going to talk about this chapter, trapping errors by using structured error handling. So this will be useful. For example, many of you have had this problem where you'll be referencing a file, maybe a picture, on your computer, and when you send your homework in, you're afraid that that reference won't work anymore because the path to that file might be different on the computer that I'm using to check your homework, or that the TA is using to check your homework. The path to a file might be different, or the file may not even exist on the computer. So this is a technique for handling that kind of situation and many other types of situations. It's basically a technique for handling errors. So here's a list of types of errors that you might want to try and anticipate and handle them using the techniques we're going to learn. So network servers, internet connections, and other resources that fail or go down unexpectedly. So you might have a program that connects to the internet, and maybe for some reason you can't connect to the internet, and that would cause your program to crash. But if you use these techniques, structured error handling, at least the program won't crash. Database problems. You're unable to make a database connection. So there may be a database that you're referencing in your program, and you need to connect to it, and maybe the wrong password, or the password has changed and the program can't connect to it. So you might use this kind of structured error handling then. Otherwise, you might end up with the program crashing. Disk drive problems, unformatted, or so anyway, these are other problems with the disk drive, problems with the path. Maybe you have a program that's trying to print something, and it's out, and the printer is out of paper, or something like that. You have a program that references some other software, and the software isn't installed. Security problems, application or process that tries to modify operating system files. You can't do it. Or permission problems. We've had these problems. The user permissions are not appropriate for performing a particular task, and our program crashed. So we try and anticipate that. Overflow errors. So that means like too much. Maybe you're trying to put too much data into a variable that can't handle that much data. For example, you try and put double into an integer, and the integer doesn't have enough space reserved to handle that much that size variable, and so that might cause a crash. Out of memory errors, clipboard problems, logic errors. Okay, so lots of examples, lots of places where we could try to anticipate a problem and prevent the program from completely crashing. So the formulation of this is not so difficult. Basically, you have some code, and you suspect that it might cause a problem sometime, and so you surround it by the word try and the word catch. And if an error does occur in this code, then what will happen is you have some other code here, like maybe just a message box saying that the user shouldn't do this, or whatever. Something here that you'll have that will run instead of this if an error occurs in here. And then you don't I don't think you have to have this, but you can have this. And this is just some code that you want to run in the case that there is an error here, but also in the case that there is not an error here. So if there is or isn't an error here, you can just have, if you want to, you can have some code here that will run in both cases, and then just the end of the whole thing. Okay, so it's not so complicated. So here's an example. I have a form and it has a button, check drive, and when I click this button it's supposed to read a file and display that file here. So in fact I'll try it. So here it is, and when I click this it shows a file. Okay, so nothing tricky there. Now let's look at the code. Let's look at the code first. So here's the code for that button, and all it does is that there was a picture box called picture box 1 there. Oh, by the way, this is not where I haven't used the or this example hasn't used the modified Hungarian notation here, which is it's better to use that, but I'm using this other book and he doesn't use that, so I'm just following along with that. So anyway, we have an image, a picture box, and we're filling it with an image, and it's just the same. We're reading from, and this is my C drive, users, bill, my downloads folder, and there's a file there called fileopen.bmp. Now suppose that I put a different name here, and there's no such file like this. Now what's going to happen when I run this? Let's try it. So if I click it, okay, so the program crashes, and we have some troubleshooting tips here, and it says file not found exception was unhandled. So that's the part of the language here. Remember, we call this structured error handling. So the point is, we didn't do any structured error handling. We didn't try to handle the error, and there's nothing in our program basically that tried to handle the error. And that's actually the language that the error message uses. It says you didn't handle the error, right? It says file not found exception was unhandled. So it's actually using the same language that we're using. We want to handle the error, and that is we want to do structured error handling. So the way we do it is like I just said, we're going to have try at the beginning. So first of all I have to stop the debugger. And so I suspect in this code, when I'm doing this code, that this could produce an error, because I am trying to read a particular file, and I know that the path could be wrong or something like that. So I might decide that I should put a try catch around this code. So I type this in, try and catch around the code, and then finally at the end try. And then I should have something in here that some message that I give to the user, or some code that I run, or I don't have to, but it would be good to have some code in here, some alternative code, or some message to the user. So I might have something like this. Message box cannot find your file. Now if I run this, I still have the wrong file here. This doesn't exist, a file like this. Now if I run this, let's see what happens. So the question is, does the program crash or not? No, it doesn't crash. I get this disk drive error message, and it says that, and then it just so it didn't crash. So cannot find your file. So I get some message, something informative, and the whole program doesn't crash. That's the point here. We handled an error. Now the language that we use here is that an error was fired, or we say an error was fired because it couldn't find the file. So actually the system generates an error, and actually another thing that happens is an error object is created. So we can actually get some information about the error from the error object. So that will be interesting to try also, and we're going to do that in a minute or two. But anyway, an error occurred, and the other language is we caught the error, and we also generated a message like this. So I'd like you to do this code and submit it as part of your homework. Okay, then as we said, besides having something like a message box, this is a slightly different error, but or actually it's the same error, but it's a slightly different message. Besides having that, we can also add in a finally clause, and as I said, this will run whether let's try this. Let's put that in there. So I put finally and some other message box here. So this message will come up whether it finds the file or not. By the way, I think in my version of Visual Studio, I can't use this, which we've been using. For some reason it's not working. Maybe it works, but I get an error when I try to use this. Let me try it again, actually. I think it's not working. Let's see, can I use it or not? I'll try it. Maybe it does work. Looks like it's going to work. No, it doesn't like it. For some reason I'm getting this error. I'm not sure why that is. If I try to run it, it won't let me run it. Okay, anyway. So let's see. If I go back and fix this so that I shouldn't get this, there's no error here, so the catch should not run. This should not be executed, but this should be executed anyway. Let's see if that happens first. I try it, and this will run in either case. That's the only thing that's executed. Okay, now let's try it. Let's make sure that it runs in the case where the error is generated also. So put a 1 here, so no such file exists. Let's try it again. So cannot find your file, and then yeah, this will run in either case. So that's what happens with the finally clause. So if there's some code you want to run in either case, you can put that here. Okay, now we're going to explore something called the error object, the ERR object. He says, as a legacy of earlier versions of Visual Basic, a useful mechanism in 2008 called the error object is updated with detailed error handling information each time a runtime error occurs in a program. Although there are newer ways to manage errors utilizing the .NET framework, such as the powerful exception object, we'll begin our work with error handling messages by seeing how the error object provides. Okay, so let's try that. So the point is that it's an object, and another point is that it's an object which gets created when there's an error. So the system, not you don't have to worry about it, generates this object when there's an error. And then the object has properties, just like any other object has properties. And one important property that it has is the error.number property. And what that will do is that will give you a way to figure out what the error is. So here's the list of numbers. So if the number is 5, for example, the type of error is a so-called procedure call or argument is not valid error. If the argument is 6, if the number is 6, the error is an overflow error. If the number is 7, it's an out of memory error. So we have all of these numbers, and you can find this list on the internet, and then so you can know what each number stands for. And the way we do this is like this. we're doing the same kind of thing. We're checking to open a file, and then catch, and we're using something new here. We say when. You can say catch when. So it only catches when this is happening. So it doesn't catch any kind of error. It only catches if we put this when here, then it's only going to catch if this type of error occurs. So what does this type of error mean? Well, the error object and its number property equals 53. So what is that? That was here, file not found. So if that kind of if that happens, if the error is if the error number is 53, that means if the file is not found, then we will catch that. Then this try will be caught, and this will be run. Okay, and then we can also do catch when error number is 7. We can have a second catch clause. Okay, so it's not just catch though, it's catch when. And so when error number 7 is out of memory, so if it's an out of memory error, then we'll have another message. Is this really a bitmap? Okay, and another and here we can also have the error object also has a description field, and we can print out the description here. And okay, and then we can have just a last catch, and this isn't catch when, so this will be run if there's any kind of error. And not only will it run if there's any kind of error, but we're also putting in this, which will print out not only problem loading the file, but also it'll access the error object description for the error and print that out as well. Okay, so this is a second project for you. So hand this in as project number 2 for your homework, and type this out and try it out. And see if you can get this error to occur. That is this really a bitmap? And the way to get that to happen is change the name from this to maybe the name of some very large file, like maybe it could be a music file, or maybe it could be just a large Microsoft Word document or something that's not going to fit into the picture box 1, so that it'll get run out of memory, and then that will generate error number 7, and you'll catch it, and then you'll have something like this. Now I'm using MSG box here, and you're going to be using message box, and you'll have to put the arguments for the message box that you're using are a little bit different than this. So so you'll have to figure out where to put the description to get it to show up on the message box. So I'll let you work that out yourself. Now, okay, next topic is you can actually raise your own errors or create your own errors using the error object. So you can just do error dot. Oh, one other thing is you can, if you want to, you can do error.clear, C-L-E-A-R. Here, you can clear the error object by using the error.clear method, which discards previous error information. But if you use the error object within a catch block, clearing the error object isn't usually necessary, because catch blocks are entered only when a runtime error has just occurred in a neighboring try code block. So you probably don't have to use the clear method. Okay, so anyway, going back to this raising your own errors, you can use the error raise method, and you say the error that you want to happen. So you put it in a try, you cause the error to occur, and then you catch it. So he says, for testing purposes and other specialized uses, You can artificially generate your own runtime errors in a program with a technique called throwing or raising exceptions. To accomplish this, you use the error.raise method with one of the error numbers in the table presented earlier. For example, the following syntax uses the raise method to produce a disk full runtime error and then handles the error by using a catch when, and it's a catch when statement here, when error number equals 61. Okay, there are other ways we can do this. Not, I mean, there are sort of more complicated ways. Like we can repeat this over and over again for a specific number of times and then stop. One thing you can do if you want is you can disable the button after a certain number of times. I'm not going to go through this, but if you want to disable a button, you can just do this. You'll see this is called button 1, but I'm not going to go over doing it letting it run a couple times and then disabling it. But you can do enabled equals false. Actually, I don't want to put it here. I want to put it here or here. So, or maybe I'll put it first here. And it doesn't matter. But now let's make sure that the error occurs. Okay, it's file 1. Okay, so you'll see what happens. So if the error occurs, this is already disabled, and it's disabled, can't use it anymore. So you can do that under certain circumstances as well. That might be a useful thing to do. Now there's one other technique you can use, which he calls defensive programming techniques. So instead of doing the try catch keywords, you can do this. You could do this, right? If file exists, so this is a method that we can call. We have file.exists, and here, so we only try and open it. In other words, this is I'm sorry, here. This part is opening the file, right? This is what we've been doing. From file, open it, right? So we've been opening it here, but we won't run this unless the file exists. Okay? So he calls this defensive programming. So we won't even try to do this unless this actually exists. Okay, so that's a kind of alternative to the try-catch method of handling errors. Then he says, well, when should you do defensive programming techniques and when should you use structured error handlers? The answer is really that you should use a combination. Defensive programming logic is usually the most efficient way to manage potential problems. As I mentioned earlier, when discussing the if-then code block, the file exists methods is actually so that's actually it actually runs more quickly than the try-catch does. You should use defensive programming logic for errors that you expect to occur frequently in your program. So if you expect these errors to happen a lot, maybe he suggests you use defensive. Use structured error handlers for errors that you don't expect to occur very often. Structured error handlers are essential if you have more than one condition to test and if you want to provide the user with numerous options for responding. Okay. So if you're interested in learning more, I suggest that you look it up. We won't spend that much more time on error handling. Okay, let's talk a little bit about the so-called exception object, which is maybe a newer way of handling errors. And also, this is actually an excellent online course, and they may continue with this next week as well. But let's look at this anyway. So this is, again, try catch in VB.NET. Okay, I made it a little bigger. And VB.NET has an inbuilt class that deals with errors. The class is called exception. So we still haven't had much chance to talk about what we mean by classes, but basically, as I said I think many times, a class is kind of a blueprint, and then objects are created that are instances of the class. So all objects that we use, they all have their own blueprints, and then we create an example of that blueprint that's called an object. So anyway, there's a class called exception, so we can get objects of type exception, just like there's a class called button, and we can get objects of a type button. When an exception error is found, an exception object is automatically created. We don't have to create it. It's automatically created by visualbasic.net. The coding structure visualbasic.net uses to deal with such exceptions is called the try-catch structure. So it's the same thing that we had before, that we've just been doing. In the coding area for your button, type the word try. So just like we did try, then hit the return key, and we're going to have end try as well, and we're also going to have catch, but we're going to have it here, catch X as exception. So this just means that we're creating an object of type exception, and the name of that object is EX. You know, we've used this kind of expression very often, this syntax very often. We said, you know, A as integer. So this is EX as exception. So we're creating an object of type exception, and the name of that object will be this. And this will occur if there's an error that occurs in the try part of the in the try block of the code. So he says the try word means try to execute this code. The catch word means catch any errors here. The EX is a variable, or an object actually. Well, it's a variable or an object, and the type of variable it is an exception object of type exception. Move your line of code from the previous section to the try part. So in other words, just put this code in here. So it's basically doing what we were trying to do before. Load a file here. And then catch EX, so we have the same thing. When running your program, VB will try to execute any code in the try part, just like before. If everything goes well, then it skips the catch part. However, if an error occurs, VB.net jumps straight to the catch, so right to here. So add the following catch part. So here we're going to take this and put it here after the catch. Now notice that this message box here refers to the object that was created. Okay? And this object, which is of type exception, has a property called, apparently, message. Right? So we're referring to that message property here, and we're getting the message box to print it out. So that's what's happening here. So a little bit different than what we did, but this is another syntax or method of handling exceptions, and this is supposedly a more modern method. Now what will happen is, if it can't find the file, we only put in this ex.message, but what gets printed out is this whole thing. Could not find the file, and it actually references the actual file and its path. So that's all contained in the message field, or the message property. Because EX is an object variable, it has its own properties and methods. One of these is the message property. Run your program and test it out. Click your button. You should see the following error message. So this message property has all of this in it. The message is coming from the additional information section of the error message we saw earlier, the one we didn't handle. So if you run this without this try stuff, you'll get an error like this, and you'll see that when this is generated, that it will say something like this. And this is also basically printing out the exception.message information. So this is actually using the same information that we're printing out in our code. So he says the message is coming from the additional information section, or actually the additional information section here is getting the same information that we can get. But the point about this new message box is that it will not crash your program, right? This crashes the program, but when we handle the exception, it doesn't crash the program. You have handled the exception and displayed an appropriate message box for the user. Now when you're programming, and testing your program, before you put in the try catch, for example, you might of course run into this error. You might get this error message, and you'll see this up here, of course, could not find the file. And you'll also see down here the view detail. And if it's 2010, when you click, if it's Visual Studio Express 2010, when you click on this, you'll see this. And this gives you more details about the error. He says if it's version 2012, you can get see it somewhere else. The first line tells us the type of exception it is. This is the type of exception. So there's an exception called file not found exception, and that's the kind of exception that was generated by the compiler. By Visual Basic. So that kind of exception was found, or was generated, and he says you can add this directly to the catch part. Previously you were just catching any error that might be thrown. Any error that might be thrown when we use this. So this will catch just any kind of error. Catch as up here. Right? When we do this, we're going to catch any error that occurred in there. However, if we want to specify for a particular kind of error, for example, if we want to specify for the file not found exception, we can type this instead. Catch X as, before we typed catch X as exception, but here we're talking about a specific exception, the file not found exception, and we can put that in here and give a specific type of message for that, and then here, if any other kind of exception is caught, we can have a different message. Now here he has the same message for both, but you could do different messages, although it won't really be the same message, because here, if it's this type of message, we'll get one message. I'm sorry, if it's this type of exception, we'll get one message. If it's this type of exception, it'll be actually a different message if it's another type of exception. Okay, and then there's one last part of the try-catch statement that doesn't automatically add in for you, and that's the finally. So we saw what to do with that before. The finally part is always executed whether an error occurs or not. You typically add a finally part to perform any cleanup operations that are needed. For example, you may have opened a file before going into a try-catch statement. If an error occurs, the file will still be open whether any error occurs or not. You still need to close the file. We haven't really worked with closing files, but you can do that in the finally part. But Microsoft advises that you always use a try-catch statement in your code. However, throughout the rest of this course, for convenience sake, we won't be using them much, even when we should be. But that's no excuse for you not to use them. Okay. So if you're learning it, it might make the code more complicated or look more complicated, so maybe he has a good reason not to use it all the time. But doesn't mean that you shouldn't use it. Anyway, this is located here, and the whole course looks like this, which is located here, and it looks like this. So it's quite a good course, it looks like. So we will possibly come back to this next class. Okay, so you have two projects to hand in for homework for this week.